are down the hall to your left, and if you need them. And so just to lead off, we always say it's a diverse organization with a 501c3 organization. ASF cannot directly support candidates for public office, but we can advocate for causes such as separation of church and state, scientific literacy, societal progress, and truthful communication. Bringing you today's Freethought of the day is Jerry Schultz, and let's give Jerry a hand. Thanks.
Good afternoon. For my Freethought of the day, I'm going to quote myself to go to one of my old Quora answers. I don't know if you've ever played on Quora, but it is a very interesting place to exchange ideas. And so people will post questions and many people will answer them. So this was a question that was posted, and then I'm going to give you my answer. The question was, as a Christian, even though I am struggling with this sin of homosexuality, how can I be encouraged in the Word of God, and how can I encourage my gay friends to seek the Lord? And my response was, you suffer from an affliction that was an accident of your birth. It is not hopeless. With study and honesty, you can overcome it. You are undoubtedly born into a Christian family and taught Christianity at birth. Had you been born elsewhere, you would have had a different religious outlook. You had a cruel and superstitious worldview imposed upon you. It is normal for people to accept the worldview in which they are raised, but people can change. Your Christianity can be cured. It's not easy, and it's certainly not pleasant. It's time-consuming, but it's worth it. Start by reading Scripture, really reading it, not reading what you've been told into it. When you read the Christian Scriptures carefully, you will find a lot that you have to explain away, a lot that you don't understand, and a lot that simply can't mean what it says. Throughout the Old Testament, you'll see a jealous and irrational God who is mostly upset over people's art projects. In the New Testament, you'll see Jesus teach something good at one moment, something that your conscience will rebel at the next moment, and something that you can't understand at all. It's confusing, inconsistent, and often endorse a morality that's at war with the innate sense of right and wrong that you were born with. Don't let that stop you. Keep reading, keep studying, keep thinking, and keep learning. Eventually, you will learn that the affliction you were given as an innocent and helpless child need not be permanent. You can abandon the superstitions you were saddled with and be free. Then you can accept your sexuality without guilt because there's nothing to be guilty about.
same frequency on one side as the other. But if the source is moving as it is in the right-hand image, the waves are compressed, so the waves on the left side of that are expanded, and the waves on the right side are contracted. Now you know this, a good example of this is if you're standing listening to a train go by. The train goes, it gets lower in frequency as it goes on. So that's the Doppler effect. So the same thing happens with light from stars. The top diagram is a theoretical spectrum of some element, atom, and when you look at the frequency of the spectrum of a star going out is shifted toward the red. That brought up the whole concept of an expanding universe, which, by the way, Hubble himself, the Doppler was the cause of this. In other words, he felt the universe, if you're talking about an expanding, it just did not make an orderly universe like he wanted. And I'm going to this in my book. But back then, in the 50s, when I was first thinking about this, I looked at, here's an electromagnetic spectrum, and it goes all the way from on the right side, very high frequency waves with high energy to long waves. And you go down, you see the microwaves. My logic was that the longer the waves were, it would be like a microwave. The answer to my one-way street scenario was the fact that the Earth and other bodies might be absorbing these waves. And consequently, I didn't know too much about it, but I asked myself the question, could long frequency electromagnetic waves be heating up the interior of the Earth? Because this was a large object. We have these waves coming in. We know even from the new James Webb telescope that there's a wealth of information in the longer wavelengths that they're seeing. I asked, could internal heat be due to this? And I knew very little about the Earth and geology, because I was mainly interested in physics. So I went out and went down to my favorite bookstore, which is Crocker and Montano in Chicago, and I got this book, and I don't know whether you can see the price of it, but back then it was something like $3.75. But this was, once again, back in the 50s, and it was a pretty sizable book written by lots of experts in the field. When I opened this up, they had one chapter that they talked about Wegener. Now, Wegener, back in 1917, he was a PhD, he was a teacher, he was an astronomer and a physicist, and he figured that all the continents originally were in one mass. And the top on the right-hand side, the top diagram illustrates this, and then it broke up and the continents kind of plowed through, like as you're going down, just like a ship would go through water, that the continents would spread out and kind of just plow through the ocean like ships. This is way back, because this is geographers and map makers way back hundreds of years ago. When they started making maps, they came up with this. This is 1858, an illustration in a book by this Snyder Pellegrini showing a possible fit between South America and Africa. And there were some thoughts. I mean, this was supposedly probably a result of the great flood that Noah had, and the whole works, a lot of religion in it. And so I looked at that top illustration, and I was trying to see how the continents fit together. Now, this illustration, by the way, a lot of geologists, in the years that have been since, have said, well, this is kind of haphazardly drawn, and it's not very accurate. But when I was looking at this, all of a sudden, it turned out that it was almost like a circle. And I thought to myself, might it be, if the Earth was heating up, that the Earth was once smaller? Well, this concept I thought was really fantastic. The year was 1958 when I came up with this, and I was working at a research institute in Chicago. There were like, 1,800 PhDs at the research institute. I'd be going around telling people that the Earth is expanding, and everybody thought that I just completely lost my mind. So I thought that this heating might be causing the Earth to expand. 1958. Well, for the next 15 years, I thought that I was the only person in the world that might have realized this. But during the Second World War, there was a lot of German submarines. And consequently, there was a big push on to try to find out what the ocean looked like underneath the surface. And what they would do is drag magnetometers and also sonar to reflect off the bottom. And lo and behold, they came up with this huge mountain range, the Mid-Atlantic mountain range. And it actually is the longest mountain range in the world. Well, this was kind of a question back then. And you see Iceland up there. It cuts right through Iceland. And also there's a part of Africa that it cuts through. And this developed into the plate tectonic theory. Now, all of a sudden, the continents were on plates, and it was the plates that were moving. And you see the two circles. One of them was around Iceland, and one of them is around Eastern Africa. And they found that they have mountain ranges, and they called them rift zones, all over the world. Lots and lots of them. So here's Iceland, and you can see the Iceland rift zone. It goes right through the middle of Iceland, and Iceland is pulling apart. That's why all the volcanoes up there. And then there's an African rift zone, which is several thousand miles long. And that, on the right-hand diagram, that part where you have, it's about Ethiopia. The part where you have Ethiopia is actually pulling apart from the rest of Africa. And here's what the Icelandic rift zone looks like. And in Africa, you have exactly the same thing, and it's quite active. It's pulling apart. So plate tectonics, as Wegener thought, was the continents were moving, but they were plowing through water. But a expanding Earth makes a lot more sense, and especially with plate tectonics. Here's a cross-section of the continental crust, which is about 35, 40 kilometers thick on the average. And underneath the water, the crust is only about 5 or 6 kilometers thick. It's much less than under the ocean than it is under the continents. In addition to this, what was I going to say? In addition to this is what under the oceans, you have a basalt layer of rock, which is much more dense than the continental crust. In other words, you can't plow through it. I mean, the rock is much stronger, much harder. What they theorize is happening, and they know this now because they've sent down bathyspheres and things to photograph the bottom. But what's happening is you have magma from the inside of the Earth coming up and pushing, and it's pushing the ocean apart at each of these rift zones. Now, how do they know that it's pushing the ocean apart? Well, the Earth's magnetism reverses every so often. And over the years, there's been a lot of reversals. Well, when they go down and drill into this and find the magnetism of the rock, it comes in bands. Every time the Earth reverses its magnetic field, you end up with a reversal of these bands. And since they know where the reversals happened over time, they can date these things. So they can go down, they can drill down, they can determine the magnetism, or how the magna is, when it's cool, retain the magnetism. And also they can do age dating. So they can not only know when it happened, but they can verify that through their age dating. Now, Berner sent me this illustration out, and it's kind of, there's several things on here. Let me see if I can. He sent this out. What they hypothesize is that you have convection currents coming up where you end up with volcanic islands, like the Hawaiian Islands. Actually, the islands are moving over where the updraft is here, and the northwesterly islands don't have the volcanic activity that the main island of Hawaii does. That's because they move out of the way. Here's the rift zones, and as they go out, and then if you have a fixed radius Earth, then there has to be somewhere. If you have new ocean floor, there has to be somewhere where the ocean floor is going. So it's hypothesized that you have what's known as subduction, where the ocean floor is actually being forced under, and where you have, like the western coast of South America, the Andes would be from pushing up, that would create the mountains. Well, in reality, there's no way, get this thing working. In reality, these convection currents are completely hypothetical. There's no way of measuring them. In fact, the largest borehole in the Earth was the Kola, I think it's Kola, and it's up where Norway meets Russia, up in the Arctic. And they went down 40,000 foot, right? I guess it's about, 8 miles. When you consider that the radius of the Earth is 8,000 miles, that's only a tiny, the crust of the Earth is just like an eggshell. That's about all it is. And there's no way they can get down there. So all these updrafts are very speculative, to say the least. Okay, Bullard was a geologist, and a noted geologist, by the way, and he kind of summarized some of the facts that were new that had been discovered since the Second World War. One of the interesting ones is the sediment on the continental shelves is quite deep, yet on the ocean floor the sediment is very little compared to on the shelves. If you would imagine subduction pushing the continent down, it would be like scraping, and you should have lots of sediment piled up, which they don't find. This worldwide series of rift zones existed where new ocean floor was being created all the time. The mantle was very much thinner under the oceans than under the continents, which we've said. Now this is interesting. None of the rocks found on the ocean floor date back more than 150 to 2 million years. In other words, the ocean has not always, or the floor of the ocean has not always been there, because the evidence, the geological evidence, shows that it isn't. This means actually that the oceans have only existed for about 5% of the entire Earth's entire life. And once again, most of the rocks covering the deep ocean floor were basalts, very dense as compared to, they were a completely different origin than the continental rocks are. Now I learned in 1974, I got a book on plate tectonics. And in there they had one chapter, and the one chapter was on a skydiving devil from Tasmania. And I saw the name, it was the first time I ever heard of it, and the chapter talked a little bit about an expanding Earth, the theory of Carey's. Well, Carey was in the Second World War, he was led guerrilla troops behind enemy lines in the South Pacific, and they'd always parachute out, and so that's how they got this idea that he was skydiving. But around 1955, Carey, who was by that time, an eminent geologist, came up with the conclusion that the Earth was expanding. And the way that he did this, and he had several concepts that, well, I guess you could probably see it. One of the things was his Riyadh concept, and geotectonics, and this is 1953, wrote papers on this. And the left-hand half shows Spain. And Spain was originally up next to France. And over time, Carey realized over millions of years that rocks, even though we think of them as being very solid, actually exhibit plastic behavior and move down. And another example that he gave in his book was that of India pulling away from Africa and Arabia. And then Carey was very big in plate tectonics. In fact, many of the primary concepts of plate tectonics, like subduction, come from Carey. And he taught plate tectonics during the 1940s and into the 1950s. And that was on a fixed radius Earth, and that's how he came up with the idea of subduction. But what he did, he was a hands-on type of geologist. And he created this great big hemisphere. And he molded plastic in the form that would just fit over, you know, it would conform to this hemisphere. And he got all the information, technical information, about the coastlines of both South America and Africa. But what he found was that every time he would try to match up the upper part of his projections, he'd get what he called a gaping gap down at the bottom. And then he would match up the bottom, and he would get this gaping gap up at the top. And he worked and worked and worked on it, and all of a sudden he realized that, and these are, that if you go on a smaller radius Earth, you have a perfect match. And this was in the early to mid-50s, and he held a big symposium down in Hobart, Tasmania. And I wrote to Carey back in the 40s, and I asked him if I could get the proceedings of this. And he said, no, he said, we've made 2 printings of the proceedings of the conference, and they're both gone. He said, however, because of your interest in the subject, he had his secretary copy the whole proceedings for me and sent me the whole doggone proceedings so I could look through it. Of course, there was a lot of geology stuff in there that was completely over my head, but Carey held this, and then Carey went and was somewhat of a politician, so he would go, and this was 1955, he had the symposium, and this is when he officially flipped from plate tectonics to expansion tectonics. And if you take away, by the way, if you take away all the oceans, you'll end up by reducing the Earth to about 50% of the radius, its radius that it is today. So Carey was there was one man, I don't remember, I think it was at Yale, who was very much of a skeptic on this. So Carey has another symposium and invites this professor from Yale down to Tasmania. And the guy after listening to all the scientific arguments on this, the guy said, well, why don't you come up and do a year of study or teaching up at Yale? So he went up and he would lecture at Yale and Princeton and Harvard, and even went up into Canada to do lectures. Carey died in 2002. I still have letters that he wrote to me and this type of stuff. But there was another fella who was his protege, and his name is James Maxwell. James worked for years for mineral exploring companies, and his expertise was telling them where to dig for gold, because he was an excellent geologist. But he decided around 1990, he was a friend of Carey's, decided in 1990 to go back for his PhD. He got a master's degree, and he got a PhD in geology, and his whole dissertation was on expansion tectonics. And it's, once again, one of these really thick dissertations. Now, by that time, UNESCO and this Commission for the Geological Map of the World went, and ever since the 50s and the late 40s, they've been measuring the depths of the ocean at different places. They've been boring down so they could find out how these stripes are, is the ocean parted. And they produced this map. It was the map mainly it shows, well, you can see right at the very top in the middle of North America and then South America under it, and then you go over and you have Australia and whatever have you. All of the really brightly colored stuff is the ocean. But even on the surface of the continents, they also did studies where they could do time dating, and the map extended onto the continents. Well, the red stripe, now this is each of these different colors is a different time period. The white stripe is what it is currently. The red on either side are where the continents or the ocean floor is split apart. And then the older part are the yellow, and then it goes down to the orange, etc. So for his PhD dissertation or work, what he did was to take out each of these going backwards in time, the same way as you watch a movie going backwards. So because of this, he generated 23 globes and a 24th, which was what he projected 5 million years into the future. So you see on the bottom, the second from the right over shows the Earth like it currently is. But then he takes out the white, and the reds move together, and the oranges, and each time he takes out another slice, it comes together. I mean, it's just like doing everything in reverse. And when he gets down to about 50% of the radius, then he starts looking at continental seas and how the debris, anytime you have water and you have erosion and things, how the debris, and he painstakingly put this all back together until he came down with a radius of about 27% of the Earth's current radius. And he's James is kind of a recognized expert in this in the world today. So I went and I contacted him, and we used to go, and this is back in the late 90s and the early 2000s, we would have the most heated conversations over it because being a geologist, he was very loose with his physics theory. So he was saying that matter kind of condenses inside the Earth. And I should make note that I had come to the conclusion that the Earth was expanding based on other influences. I wasn't a geologist. I was looking at it from more of a philosophical physics standpoint and philosophical standpoint of the universe. Where Carey and Maxwell and others had come to it is through geology. If you study it, tells you that, it all facts, everything kind of fits into place. So we used to go and, for example, here's a time scale that I put in my book. And down around, I think it's about 500 million years ago, which is only, the time since then, it's only been about 11% of the Earth's history, you had a life form. And this is, I don't know how big it is up there, but the oceans actually started being formed. They had vast intercontinental seas. And the oceans, because of the expansion, you began to get breaking apart to form the oceans. And these only started about 250 million years ago, which is only about the recent 5% of the Earth's total history. James has this website, Expansion Tectonics, and I helped him put together a lot of it. What we did is we had if you go up to expansiontectonics.com, you have to turn off your thing to prevent pop-ups, because I pop up a second window, and it shows you both each quarter of the Earth, 0 degrees, 90 degrees, 180 and 270 degrees as pictures, and then the North Pole and the South Pole. And then on the second part, you can run your cursor up and down, and you can see how it changes, wherever you look. You can see the oceans pulling apart and everything else. We used about 11,000 images to create this effect on his website. Now, if you have an expanding Earth, what happens is the crust is relatively rigid. And if the radius changes, then you have in the continent, you can see on a smaller Earth, what is it? Well, in the smaller Earth, the continent would actually rise up to, in this case, he's calculated 580 kilometers high. But naturally, it's not going to do that because it's so heavy. So what happens is that the continent comes down, and as it's coming down, the corners where it was rise up. And this rising up is what creates the fodder for mountain ranges. What happens is as the edge comes up, then you have erosion cut out the mountains from the plateau that's risen up. And this is why in the mountains you find fossil sea creatures up in the high mountains, high mountain areas, because you actually have this push-up. Now, there's another man that in fact, he was after me to write my book for a number of years now. His name is Cliff Ollier. And Cliff was probably one of the foremost experts on mountain building in the world. He's written books on it. He's done over 200 peer-reviewed papers. He's very highly regarded. And and this is from his book on the mountains, you see on each of these things from South America, Australia, what happens is the interior goes down and forms a valley, and the sides come up, and then the erosion eats away the mountains. Now, there's evidence in support of expansion tectonics. I'll go over a little bit of it. One, there's geographical information. In Maxwell's constructions, as he comes back, everything fits, and he can therefore plot where the poles were and also where the equator was, which gives him a lot of information. And his reconstructions show you why, when you go up to Alaska, you have ancient coral up in Alaska, which it shouldn't even be. What happened, where you can visualize this, is that the continents, because of the expansion, the continents move and separate from each other. In fact, Australia used to be, now it's like this, it used to be up against western North America and the Panama area and South America. And it's shifted, it's actually rotated. And geological evidence will show you that Australia has 3 different zones. One of them is very similar to the western United States. One of them is very similar to South America. And one of them is in the zone, in between the two. And Maxwell, being a geologist, I mean, he really, but I regard this equator and polar information that he has is just completely superior to anything that anybody else has done in that. You have a lot of different features as he pulled out and took away the slices and brought everything back together. Everything fit like a glove. James claims it's like 99%, over 99% fit in going back. But because items rotate, you end up with things like, what is it, the sloth? The 3-toed sloth and 2-toed sloth. Well, you have those in Australia, and you have them in Central America. But that's the only places in the world. And the reason you have that The reason you have that is because they migrated in, and when it broke off, the sloughs were in both places. There's another fellow by the name of Dennis McCarthy who wrote an excellent book. He calls it Here Be Dragons. And he goes and looks at the Pacific, he calls it the zipper effect. And he looks at species as the Pacific opened, and the places where you have maybe an island with 5 miles to another island, they both have the same species, or they both have the same, species, but they're completely different from one another. There's no way that they could be the same because they've evolved so much. You end up with the mountains and rifts and volcanoes as evidence. Cliff Ollier, by the way, is very much of an expansionist now. You have what's a new Tourette. There's one fellow by the name of David Noel down in Australia that studied trees and plants. And he said that, you'd think that if everything was together, you'd have species going over, but he said no. He said, even you'll end up, each species has this particular niche. And if you have, he gave an example. He said, imagine you have some type of a plant, and you have these plant seeds going out. He says you'd think that they would grow until they encompassed everything. He said that's not true. Each one goes into a particular niche, and he wrote a book on that, which is available on Amazon. And then you have fossil evidence. And the fossil evidence we definitely have, and another friend of mine in the UK has written a book on that. And his book was about dinosaurs. And by the way, in my book, I have lots of other references, a ton of references in there. Now, here's something that's really interesting. The South Pole has migrated. Let me get out here a second. The South Pole began up around here, and the migration path has been down like this, and right now, of course, it's down in Antarctica. Well, it wasn't really the pole that migrated. It was South America as a splitting. That's where you end up with this apparent migration. Right now, it turns out that the Antarctica is sliding over the South Pole. It's not, and something else about this is with pole wandering. What James has found is that you don't have pole wandering, which is, to me, very logical, because you have an object as big as the Earth rotating around. You think of a gyroscope and going around with its mass, and it resists any kind of movement. If you have something the size of the Earth, and the mass of the Earth going around, you're going to be hard-pressed, I think, to explain any kind of movement around the axis of rotation. Now here's Stephen in his book. He talks about dinosaurs. And Stephen is a structural engineer in the UK. And Stephen maintains, from the standpoint of actual structure of dinosaurs, according to their bones, which we can measure, he says it's impossible under today's gravity to have any kind of dinosaur or big creature development. Simply, it is structurally impossible. And he wrote a book about it. Now that his book is in the 3rd edition and is quite popular. Now, here is a curve that from James Maxwell. By the way, James became a good friend of mine. We've known each other now 25 years. And about a dozen years ago, he came over and he and his wife, and they spent a whole month with my wife and myself. We went through the Southwest, which was amazing. You have a PhD geologist, and he would point out everything, all the different rock formations and everything else. And then he spent time in about a week in Little Rock. But on this, the dinosaurs actually were at a place where the Earth's radius was about half of what it is now. And because of the gravity is an effective mass, if it's half the radius, the volume goes up according to r cubed, the radius cubed. And so there was a lot less gravity back then. And he said there's no way that you could have had this. Well, anyway, James plots this back and with his reconstructions. And he comes back to a point about 2 million years ago, about half the lifetime, where he says the Earth wasn't expanding at all back then. And I tried to say, well, there has to be some. He said, no, well, I don't believe there wasn't expanding at all. But with any kind of an exponential curve, you have a little bit of it, a tiny bit of it as you go on in time. So what I did is I took this graph of his. Well, here's 2 quotes. One from Cliff Ollier. The world's distribution of volcanoes does not support the idea of subduction and compression around the Pacific Ocean or on island arcs. To maintain the view that volcanoes can erupt in a compressive zone, which with subduction, that's why they say that you have the Andes and the volcanoes on there, requires suspension of belief in Hosono's law. Volcanism does not take place in the compressional crust. And then you have another quote down here. The special problem of the trench is in conflicts the theoretically compressional nature of plate boundaries and why the apparently tensional nature of the trench itself. Indeed, why the collision of 2 rigid plates should produce a trench is so far unexplained. Now, I took this slide shows you the same thing as before, but it was talking about different life forms. You ended up with some life forms going back there, but when you get back to about 500 million years ago, you have very, very primitive life. So I took this chart and I expanded it out to all the way on back to 4.5 billion years ago. And once again, according to James, I kept it flat with very little expansion back there. And at the top, I plotted an exponential curve. And it shows you it goes right according to an exponential curve. And the early radius from Maxlow, now I say this because I'm going to talk about somebody else by the name of Alfvén, who was a physicist who won Nobel Prize in Physics in 1969 and is kind of considered the father of plasma technology. So remember this, Maxlow, independently, knowing nothing about Alfvén, came up with a radius of about 1,700 kilometers. Now sometimes you end up with some unexpected evidence. I wasn't only looking at geological evidence, but also I was looking for, I started out writing a book, and I was looking at cosmological studies. Now, Alfvén went in back in the early 1940s, was very interested in the solar system. And so he was trying to find relationships. And 2 things he came up with. One of them was he looked at the 4 large planets, Jupiter, Saturn, Neptune, Uranus, and the 4 inner planets. And this was in 1942, he published his first paper. And he was plotting, and what he would do, he would take a large cube, where it's the mass, he would take the mass of the nth planet, and you divide that into the mass of the nth plus 1. And the planets he just numbered like this. So, for example, you would take a cube is the mass of Venus divided by the mass of Mercury. And he did this exact same thing for the large planets. But what he found for the large planets, if you end up with 4 planets, he'd have to take one point between Jupiter and Saturn, 1 point between Saturn and Uranus, and 1 point between Uranus and Neptune. So you end up with 3 points. So he plotted the points, and he ended up with this being 1 point, this being 1 point, this being 1 point. Now, theoretically, in the other work that he had done, he came up with the reasons for this, and that is because the large planets accreted from So he did this, and lo and behold, he came up with a radius of 1,700 kilometers. Now, this is done in 1942. Maxwell's was done completely independently. Both of them came up with the same number. As our Earth-Mars dot is the only one in which does not fall on either of the curves, one must seek a cause of this exception. We should expect it to fall on the second curve because Earth and Mars are both inner planets. If we suppose that it does so, and further assume that there is no error in either the small q value or in the mass of Mars, we can calculate backwards. The mass we find agrees with the mass of the Moon. Now, in Alphen's work over the years, he's written several other papers, he's written books. In fact, Alphen was one of the people that NASA paid, funded research for 7 years, where he and another fellow from Scripps went and wrote a very big book on the evolution of the solar system. And so Alphen, for years, was studying the solar system, and he couldn't figure out why should you end up with such a difference, you know, the radius. But the radius, to me, this is just an unexpected point to show that the radius of the Earth back then was smaller, and it had undergone growth. The Earth experienced virtually no growth in the first 3 billion years, which in my mind brings up some important questions. Why was there no apparent growth, according to Maxwell, for the first approximately 3 billion years? And second, why did the Earth experience exponential growth for approximately the last 1.5 billion years? And where's this new mass coming from? Well, the question that's always asked is, where does the new mass, if the Earth is expanding, where does the new mass come from? And Maxwell has told me time and again, he'll give a lecture, and everything, I mean, a room full of geologists, they can't find any fault with any of the things which he's saying. And then he says he'll have some guy in the back stand up and say, hey, where's the mass come from? And Carey faced this problem. In fact, Carey wrote about 4 or 5 books. And this has always been a question that Carey was asked. You know, where does this mass come from? So Carey spent the last 25 years of his life trying to figure out where this mass comes from. And to no avail. He tried to examine everything. I mean, there's a whole list of about half a dozen places, you know, meteorites coming in. No, it doesn't fit the bill. And expanding Earth and contracting Earth, like the possible universe might be. No, that doesn't fit the bill. And so Carey knocks down each of these. Different explanations. So this has always been a bugaboo. Where does this extra mass come from? About 10 years ago, 12 years ago, this has always been one of the things which I've been most intrigued about the expanding Earth. And so I went and came up with the idea. I knew there was a lot of water on Earth, and you know, you end up with, if you want to look for anything which reflects the growth of the Earth, it would be the mass of the water on the Earth, because as the Earth expands, you end up with more water. So I thought water might have something to do with it. Alphen came up with the concept of plasma cosmology. And I was deep into the plasma cosmology, and everything was with plasma, because something like 99.99% of all of the matter in the universe is plasma. And all of Alphen's theory about the evolution of the solar system is all based on plasmas. And so anyway, what happened with the Earth, you end up with as the Earth is accreting, beginning its initial growth. And this is all due to plasma. There's a whole theory, but I could give you a whole talk, the theory behind this. But what you ended up with is the particles hitting the Earth would stop and generate heat. You know, the energy has to go somewhere. And so you end up with a period of time early on where you end up with a lot of heat, which is, you have to have, from the standpoint, there are certain geological rocks that only can form in high temperature environments. But then, and also, back then, you did not have surface water. Most of the water was tied up in solids like it is today. But then you end up with the liquid water. Now this diagram is from one of Alphen's, or actually there were a couple of Alphen's articles and books with this in. I tend to think that it should be that red line is probably more realistic to how you actually ended up, because it matches the growth of the Earth. Because Alphen assumed that the Earth has always been its current size. All these people have always assumed that the Earth has been its current size. And so I know that electrons are very easily conducted. I was very curious to whether protons are conducted, because in order to make matter, you have to have electrons and protons. And I find, lo and behold, water and ice are fantastic conductors of protons. There's a thing called the Grothaus mechanism. Also, the mantle of the Earth is a very, and they've shown this with actual experimental studies, is an actual proton contributor. So my thing is that you have to have protons from the standpoint, you're just shaking your head, no? You have to have protons in order to create mass. And so in my book, I go into a whole section on the mechanism, this mechanism of mass production. I wrote an article back in 2011 on this, and then I wrote another chapter in a book that came out in about 2020. And in my book, I go into it in more detail, and this was interesting. So I ended up by finishing up my book. It's on Amazon. I have a couple copies here. Burns said that I should bring a couple in case anybody wants to buy one, but I have a couple if anybody's interested. But it goes into the whole thing. I have 150. Everything I said, I wanted to have some kind of a reference. So in my bibliography, I had references to any of the points that I was making. Have a good index in that. And then I went, and then when I started out, way back around 2008 or so, I wrote this big thing when I was doing my master's degree, that I wanted to have a book on the infinite universe. And so I pulled out all the stuff concerning expansion tectonics and put it in this book. And now I'm in the final process of doing my next book, which is called An Infinite Universe. And it goes into concepts of philosophy with the universe and the evolution of the solar system and plasma physics and lots of other topics and a lot of questions. If you're going to have an infinite universe, what kind of constraints does that put on the universe? So if you have any questions, I'd be anxious to answer it or try to. Yep.
Yeah, I got a lot of objections. I'll try not to monopolize this, so I'll stay away from things like exotic explanations of protons flowing through rocks and cold fusion and all that. Stick with what's always been kind of my center in life. I grew up surveying.
Mm-hmm.
Measurement has always been the central part of what I think is important. When I went to the Wikipedia page on expansion of the Earth, it went through much of the history and had some modern objections to the idea and why almost all geologists believe in plate tectonics.
Yeah, there's a lot.
And it had played
Mhm.
This is smaller than the bulge of the earth. So why not accept what is in every geophysical journal as being what the actual rate of expansion is? This is using the best technology known right now, unless you know something better. How do you answer that measurement that they have? There are also several other papers that use other techniques, completely independent, that make estimates that go back to 600 million years.
Right. No, I understand that. In fact, Wu is one of the people that has commented on the work that James has done.
Pardon? I don't
Wu,
hear well.
Wu is one of the people, he's Chinese, isn't he? A group in China? Wu?
Right.
Yeah, he's one of the people that has commented lots on what James has found out. The only explanation or the only thing I can really tell you is read some of the technical information, aside from just this one paper, from geologists throughout the world. I know there's a friend of mine in Poland who has been teaching Earth expansion, and he's written several books. And one of the books are this, I think he's called it the 7 Proofs of Expansion, things which are you cannot explain, like the rift zones and triple point rift zones. Now, I'm not a geologist, so I'm not able to talk to you from the standpoint of geology and show you the geological stuff. I could direct you to lots of different papers, because I know when I'm doing the research for this, there was an awful lot of different papers. But there's a hell of a lot of people in the world today that think because it's been written for so many years that church is really good and there's a God. I don't know. I'm not trying to argue or dispute with you on that. I'm aware of the fact that not everyone thinks that way, but I also am aware of the fact that not everybody that is a skeptic has done extensive research on their own into the subject matter. I agree with you. 98% of the geologists today don't believe the Earth is expanding. One interesting thing was that Maxwell, it turned out that about 15 years of, I guess, maybe even longer than that, when he was doing his PhD thesis, he ran across a thing with geodesic data from satellites where you can measure down to the millimeters, from the standpoint of the distances. And the information showed there's a variation in different sites of the Earth, up and down. And he couldn't figure, it looked like it was averaging out to 0. And he couldn't figure this out. He went back and looked at the raw data. And it turned out that the people that had done the study had variations, and they just assumed the Earth was a fixed size. And they ended, No, they assumed it, and the computer programs which calculated and reduced the data, actually they built in a correction factor into the program, forcing it to be a certain size. Now, if you want to go real technical on this stuff, all I can do is to provide you with references that I think would satisfy you if you looked into it enough. But I know I am completely aware of the fact that 98% or maybe 95% of the geologists don't believe the Earth is expanding. But no, I have no objection to that. I mean, I'm in full agreement. But I think that the technical literature and those people who are skeptics have not, for the most part, gone into it deep enough so that they look at the evidence of expansion. I mean, there's certain things, like the rim of the Pacific Ocean keeps getting larger. The rift zones around Africa are expanding outward. There's no subduction. What?
That's not evidence.
What's evidence?
There are a dozen different ways to explain that, and that is not of itself evidence.
Well, I don't know,
I'm saying that the most straightforward way of answering the question of is the earth expanding is measure it.
you know,
And this is exactly what Wu and his team did. And that all of the data that they
oh,
use is publicly available.
oh, yeah.
You could go out and do exactly the same thing yourself by going to publicly available data from GPS, from very long baseline interferometry, from all the rest of that. Those are publicly available sources.
Oh, absolutely. Now, I have no idea how old you are, but I think that that I would like to bet you that it's going to become apparent, grossly apparent, that the Earth is expanding because over a period of time because of geodesic information. This is one of the things that we can measure. We can measure the Earth from the standpoint of satellites. And it's bound, I don't know whether it's going to be 50 years from now. I mean, if it's going to be next 10 years, 5 years, or whatever, I make a bet on it. But over the next 100 years, it's going to be irrefutable evidence that the Earth is expanding. I firmly believe that, no matter what, anyone says.
So there was a plot you showed from someone named Alfred or something like that, that showed the relationship between the planets, inner planets versus outer planets.
Yeah,
and this
yeah.
Smooth curve where they fit. And the Earth was an outlier in that curve, right? So why would the Earth be special? Why would it be absorbing energy differently from Venus and Mars?
My guesstimate is that one, you have water on the Earth. And I think water, I'm convinced that I could go into the, I could talk about the evolution of the solar system, but I think that water on the Earth is water and conductivity. And it turns out that the theory of evolution is from the standpoint of early sun pulling particles in, and the particles, because of they gain velocity, enough velocity that they have kinetic energy and they heat up and they ionize. And the magnetic field of the sun stops them in the same way as you have two magnets with opposite poles stop. And you get a transfer of momentum to these particles, and as they gain more velocity because of the sun's rotation, it's a magnetohydrodynamic effect. They will gain centrifugal energy or force and move down to an equatorial plane of the sun. And then they will they will deionize. And when they deionize, they go into an orbit of eccentricity, eccentricity 1/3, I believe it is. And then it goes as a Kepler orbit. And then because of the interaction of the Kepler orbits, they accrete over time in a band. It's almost like a torus. And with the accretion, and there's a fellow by the name of Ernest Eichler, who was, in fact, this guy they even named one of the near-Earth asteroids. They named it after him. But he did work, and he was talking about the accretion, and the general consensus of both Alfvén and Opic and a number of other people is that the moon and Triton, the satellite of Neptune, are both acquired planets. The moons are acquired because they're in retrograde orbits around. There's only like 10 satellites that are in retrograde orbits. And the moon and the Earth accreted in the same orbit. And the Earth acquired the moon in this retrograde orbit, which it can. And also it goes to explain the distribution of angular momentum in the solar system, because the sun, which is the largest, has only a couple % of the angular momentum of the solar system. And the angular momentum was based from the standpoint of this accretion, and the accretion drained off the angular momentum of the solar system. Now, Alfvén went into this in detail. As I say, he wrote a big book for NASA on that with another fellow. And this is, but my feeling is that one of the reasons why the Earth has grown like it has is because of the electromagnetic field of the Earth and because of conduction within the Earth. And the big question in my mind was, can protons conduct? And yes, they can. There's been a lot of work and books written on conduction of protons. And you mentioned cold fusion. Well, I read a half dozen books and a number of papers on cold fusion. And our government and other governments have put millions into cold fusion research, and they've had spotty results. Really, spotty. But at the same time, there are examples where energy is produced and you can't account for it. And there's something going on. I mean, if the Earth is indeed expanding, there is some mechanism behind it. And I don't know what it is, and I don't know whether we'll ever know what it is, but we will know, I'm convinced, that beyond a shadow of a doubt, the Earth has undergone expansion. I think it's inevitable, especially with today's space technology and geodata.
The question I often have when people are debating this type of scientific question is, what difference does it make? In other words, are there any practical applications if you're right or if you're wrong?
No.
Are there areas that we should be exploring if you're right? Other areas that we should be exploring if you're wrong? What is the difference? So it's kind of a so what question.
Well, I don't know. One, I think it's just simply so that we know. I don't know whether there's any practical applications, but it's awfully nice to know how these things came about. It's, I agree with you. There's, so what? but at the same time, there's too many cases. Well, in fact, in the book, what I did is I took the 2 articles that I wrote and put them as appendices in my book, and then I took one which I wrote for my master's thesis on paradigm shifts. And typically with a paradigm shift, you end up with nobody, some guy or a little group thinks that they have something, and you end up with contradictions coming up. And when the contradictions come up, then it's inevitable. Then all of a sudden you get this avalanche down where everybody accepts the new idea. I think that expansion tectonics is going to be one of these things. What I did is I laid out several books on the subject. I have quite a few more than this on the table back there if you want to take a look at them. But there's been a lot of people around the world that have been working on this, and there's some growth of interest in the subject right now.
Any further questions? If not, appreciate you, John, and thank you again. Everybody give John a hand. Thank you.
Thank you.
All right, so our cadence is a little off this month since we moved our meeting a week later than we usually do to make room for the Secular Student Alliance Conference. But we do have several meetups coming up on our meetup.com page. You're welcome to, take a look at those, and I'll read off a couple of them real quick. The best way to keep up with events is to, use the Meetup app on your phone, and then at a glance you can see what's going on. We've got a lot of stuff all the time, always. So coming up, we've got a Zoom night tomorrow at 7:30. The link is available in Meetup. We advertise for Socrates Cafe. That's a third-party group that's meeting up on Wednesday. On Thursday, there's Beyond Belief Secular Substance Abuse Recovery. If you or someone you know could use some assistance on that, it's just a quick online get-together in a secular space, which is kind of rare. Looking ahead, first Tuesday, our meetup at American Pie Pizza in North Little Rock will be on July 2nd. So before you go wild on the 4th of July, go wild on the 2nd of July. And then, of course, we continue the usual cadence with Zoom nights on the second and fourth Mondays of each month. And on Sunday, July 14th, we've got a second Sunday Cantina Communion at Cantina Cinco de Mayo off of Stagecoach Road, followed by Pint Night at the Flying Saucer on July 15th. So plenty of stuff to do on the social calendar, and I would encourage everybody to, get involved and, keep in the loop on those kind of things and get out and have some fun this summer. And if you have not yet joined ASF or, helped us out, you can do that on the arfreethinkers.org website. Dues are dirt cheap. It helps us to keep our website and other infrastructure up and running. There is also an opportunity. These events that you see are organized by just regular people like yourselves. There's an opportunity there that you can do, potlucks, book clubs, a family meetup, a dog walk, a hike, whatever you'd like to do. There's an opportunity for you to use this as a way to meet other freethinkers who might share those interests. So we need volunteers also. We need people to join the AR Freethinkers board, and we need people to help us out with little tasks. You have special skills, legal, technical, carrying stuff around, whatever it is, we have a need for it. So let's continue the conversation afterwards. I've got a couple of little snacks outside, and I will see you all next second Sunday in July, where we won't see each other the second Sunday of July because we're mixing up July too. We're going to meet on Thursday, July 25th, not Sunday, to talk with Brian Dunning, a filmmaker who has made some excellent documentaries on UFO skepticism, kind of breaking down some of these claims of UFOs that people have seen, but also, on the other hand, looking at the odds of us really being alone in the universe. It'll be definitely a worthy discussion. I would encourage you to check out his work ahead of time. So, all that said, thank you very much for making it out today, and I will see y'all on July 25th, a Thursday. Talk to you later.